It all starts when one oxygen atom meets two hydrogen atoms, and they decide to form a covalent bond. See, oxygen is highly electronegative, meaning that it attracts electrons. The electrons of the hydrogen atoms are pulled towards the oxygen. Since electrons have a negative charge, the oxygen atom is now slightly negative, and the hydrogens are slightly positive. And boom, it's a magnet. Well, no, not exactly, but it is a polar molecule, and that polarity is very important to life on Earth. When a few water molecules are put in close proximity to each other, this starts to happen. But why? Well, the negative oxygen attracts the positive hydrogen of another atom, and vice versa. This is called hydrogen bonding, and it's the reason water is so cool. Thanks, hydrogen bonding. You've probably realized by now that water is essential to life, but it's important in a lot more ways than you might think. So let's go back to that hydrogen bonding over there. See how the water molecules stick to one another? That's called cohesion, and it's responsible for a lot of the cool properties of water, such as adhesion. Adhesion is water's ability to stick to other substances, and it's the reason for capillary action, or when water in a tube adheres to the side and begins to climb up. This is how trees and other plants get water to their leaves without moving. Another property caused by hydrogen bonds is high surface tension, meaning that it takes a bit of effort to break the surface of water. The hydrogen bonds on the top layer of the water will allow the molecules to cling to each other, forming a kind of film that can hold up very light things, such as this bug, but can't hold up something with a lot of weight, which is why this cow sinks to the bottom. Let's take a minute to talk about animals in lakes. See, when water freezes, it stabilizes the hydrogen bonds that hold the molecules together. The molecules end up getting pushed apart from one another, making the ice less dense than the liquid water, so ice floats. If ice sank, it wouldn't be able to act as an insulator for the liquid below it, which means that the liquid would also freeze, and we would have some very frozen fish. Water also moderates the temperature of the air around it. Water has a very high specific heat capacity, meaning that it takes a lot of energy to change its temperature. This, too, is due to the hydrogen bonds. To alter the state of water, you have to pull apart the hydrogen bonds, which takes a lot of energy. This results in a lot of energy being used to heat water, and less energy being used to heat surrounding land or air. And finally, the universal solvent, or water's ability to dissolve a lot of substances. When the molecules of a substance to be dissolved, or solute, are placed in water, water molecules immediately begin to attach themselves to the different atoms of the solute molecule based on their charge. The positive hydrogen atoms attach to any negative particles, and the negative oxygen atoms attach to any positive particles. The water then begins to tug at these particles using its polarity, and eventually will break apart the substance, dissolving it. I hope you found this helpful in understanding the polarity of water. Thanks for watching!